Hello, AP Environmental Science students. Happy Friday. And if you're watching this later, I hope you had a nice Friday. So my name is Dr. Sowell, and I teach APES in Jacksonville, Florida. So quick reminder about our exam date and times over here on the left-hand side of the screen. And on the right-hand side, you can see a description of the 2 FRQs that are going to be on the exam. So worth looking at. Another reminder, I know Ms. Fassler and I both mentioned this the last couple days, but a really great resource is the College Board's update page about tips for success on open book, open note exams. I would definitely take a look at that. I know from my students, I've had them take a look at this and really think about what kind of notes they're taking during these review sessions. And then finally, a final reminder, on your AP Classroom, when you log in, you will see a new place that says practice answering free response exam questions. You now have access to a few more that you may not have seen before, and it's a place for you to, practice writing them, looking at the rubric, see how you did. Just another resource to get you ready for the 18th of May. All right, so let's go over the homework from last night. This is the 2017 question number 3 FRQ that Ms. Fassler assigned last time. And this is all about the island of Hispaniola, which houses the Dominican Republic and Haiti. And there's this unique way to visualize the border between the two. You can look at rates of deforestation. So question A said, provide one reason why deforestation commonly occurs in a less developed country like Haiti. So you could have said things about clearing for agricultural land or to produce charcoal. Ms. Fassler showed a really cool picture the other day of a charcoal stand somewhere in Africa and how that charcoal is used for heating and for cooking in homes. You could have said for building materials or just clearing land for human use, roads and homes and stuff. So let's look at a student's response and see what they said. Deforestation is more common in a less developed country like Haiti because their economy and government isn't getting strong or developed enough to put deforestation regulations in place. This means that there are less consequences to companies that clear-cut forests. There you go. One reason why that might be happening. All right. Here's another example of the strategy. So here we're looking at the strategy to reduce that problem. So this person said a realistic strategy to reduce deforestation in these less developed countries is to subsidize companies if they don't clear cut, but instead cut down trees in a scattered, more sustainable manner. This way, the companies can still use lumber, but the trees will grow back in a manner that ensures ecological resilience. Absolutely. So putting in regulations or laws or subsidies that promote more sustainable forestry practices. An interesting 2 down here at the bottom, reduce population growth. That would be one strategy to reduce the demand on the forests. Or ecotourism, shifting the revenue from chopping the tree down to going visiting the tree in a park per se. All right, so now this will be 1 point for this person. Let's go to B. So B says deforestation can affect water quality. Identify one change that can occur in the water quality of streams within a watershed that has been deforested. Explain how deforestation can lead to this change. So this is an identify and an explain. 1 point for identifying the change in water quality and 1 point for explaining how deforestation caused that change. All right. So you could have said an increase in water temperature because there's less shade. There is an increase in turbidity because there's more erosion and runoff. There's more nutrients because of loss of vegetation reduces the amount of assimilation of nutrients and that runs off into the stream. Same thing for pH and DO. So let's just see what this person said. One change that can occur in the water quality of streams within a watershed that has been deforested is that the water quality will be bad because there are no trees to filter and clean the water, and there will be more water because the trees also absorb the water, but without it, it will flow straight down. So unfortunately, this did not get any points. Describing the water quality as just bad is too generic of a term, too general, too vague. And it doesn't sound like you've taken an APES course. An APES student would be able to describe water quality in ways other than just bad. And then the second part of their answer here talked about the amount of water, not the quality of the water. C, identify 2 environmental benefits other than those related to water quality of maintaining forest ecosystems. Remember, many times on an FRQ question, there will be this clause that says, other than blah, blah, blah. For whatever reason, that's a nice place for our eyeballs to sometimes scan over. So slow down and read your questions really carefully. So other benefits from the forest might be to deal with excess carbon in the atmosphere. It releases oxygen. It's involved in biogeochemical cycles. It reduces erosion. Lots of things other than water quality. So this person said, forests are a vital carbon sink and producer of oxygen. They help to reduce greenhouse gases and produce clean air, reducing impacts of climate change. Trees and forests provide habitats to important species that may provide a variety of ecosystem services. Okay, 2 things identified: carbon sink, habitat. This person said for the same question, 2 environmental benefits of maintaining a forest ecosystem is that it provides a place for animals to live, it's their habitat, and it will increase or keep the biodiversity. Well, unfortunately, that's only worth 1 point because that idea of habitat and biodiversity is really almost considered part of the same idea. It's not a whole separate idea, so only 1 point there. All right, then the next one says, identify and discuss one factor in a less developed country that could contribute significantly to a change in life expectancy, similar to what occurred in Haiti from 95 to 2015. So in those 20 years, we saw the life expectancy in Haiti really increase. Why? You had to identify the factor and then how that contributed to an increase in life expectancy. So increase in healthcare, turned into prevention of early death because of vaccines, or fewer pregnancies, so fewer children resulting in fewer maternal deaths. So you had to identify a factor and then discuss how that factor contributed to life expectancy, not just describe that factor. So this person wrote, the adoption of advanced medical techniques and technologies could increase the life expectancy as well as reduction of harmful pollutants. So this is only getting 1 point for the advanced medical technologies, improvements in healthcare. The second clause here, as well as reduction of harmful pollutants, that's a whole different idea. That does not explain how that factor contributed to life expectancy. This person said an increase in healthcare in a less developed country can greatly increase the life expectancy in that area. When people take better care of their health and have more access to medicines, they are able to live longer and fight disease more effectively. So there's 2 points. An increase in healthcare, there's our 1, and then there was a good description of how that factor increased life expectancy. So a good, robust, full answer there. E says identify and discuss, so same pattern again, one economic or cultural factor in a less developed country that could contribute significantly to a change in the fertility rate, similar to what occurred in Haiti during these 20 years. So the fertility rate went from 5.2 to 2.7. Why? A lot of things in terms of education and equal opportunities for women, industrialization and economic development. So again, you had to not only identify that factor, but discuss how that factor dropped the TFR, or the fertility rate. So let's look at a student sample. Increased education for women would increase the number of women in the workforce. The more women in the workforce constitutes a lower fertility rate. Another possibility is increased access to contraception. Now, this is only worth 1 point because they did identify an increase in the women in the workforce, but instead of going on to explain how that contributed to a drop in fertility rate, they jumped to a completely different idea about contraception. So they get the 1 point for the identify, 0 points for the discuss. All right, so let's jump into some new stuff. So we're going to wrap up Unit 5 today. We're going to start looking at mining, the impacts of mining, the impacts of urbanization. We're going to look at the concept of an ecological footprint. And finally, we'll look at some solutions and methods to reduce urban runoff. Now, just for the purposes of how I've organized this, I'm not going to go in this exact order. I'm going to jump around a little bit, but we will cover everything. All right, so what do you need to know? 511 is footprints, ecological footprints. You need to know what a footprint is and what are the things used to measure it. So to get there, we are going to describe what goes into a footprint and then talk about what that can tell you about consumption and waste, both at the per capita lens and the per country lens. So what's the footprint? It's a way to measure the human demand on the environment. It's really looking at the amount of land and water you need for the resources you use, as well as the amount of land and water to take care of the waste you generate. And this can help be a really useful tool in understanding, are we using our natural resources in a sustainable manner? And what could we do to change? It's nice a way to quantify things that for a lot of us seem very nebulous and unquantifiable. It's a way to give us a lens on our consumption. And what we can do is once you find out an individual's ecological footprint, you can simply multiply that by the total population and get a generalized footprint for the entire country. Because again, this is not just about population. We talked a lot about population before in the previous unit. So our environmental issues are not simply we've got a lot of people. That's part of the problem, but it's also that certain ones of those people, certain individuals, consume and generate more waste than others. And we'll look at those differences here. So before we do that, let me give you a short animated little clip of what a footprint is, ecological footprint.
Our human activities consume resources and produce waste, and nature needs to have the capacity to meet these demands. The ecological footprint is a way to measure our human demand on nature. Every one of us has an ecological footprint. The footprint represents the impact of a person, a household, a city, a business, or a country on nature. Things like food, energy, transportation, goods and services all contribute to our ecological footprint. The footprint is expressed as the amount of land and water required to produce what we consume and to absorb the waste we generate. By measuring the ecological footprint, we can assess the pressure our lifestyle puts on the planet. This helps us to manage our ecological assets more wisely and to take personal and collective action.
So because this is something that we can quantify, it may be something that might show up on a data table or a chart. So it's good to look at some actual numbers for this. So this is usually measured in hectares per capita per person. So for example, the global average, the average human being right now uses about 1.7 hectares or about 4.2 acres. The average US citizen though uses 8.1 hectares or 20 acres. Compare that to Spain, which is about half of that. And then we look back again at Haiti, and the average individual in Haiti has 0.7 hectares or 1.7 acres. So again, some wide variation. And you could start thinking of reasons for that in terms of economic development, standing or the location and the demographic transition where they are, and then population. So this is a nice graphic of the per capita. So the darker numbers indicate a darker per capita ecological footprint. So you can see some pretty dark colors here in North America and in Europe, and some parts of the Middle East and Australia. And then we can shift and look at that into a graphic form, more of a data chart or a graph. So you can see Qatar is around 16. So this is per capita. So the average person in Qatar is having the largest ecological footprint. And then it kind of goes down, and you can see the United States is around here. Estonia is in 10th place. So this is the top 10 countries with a per capita ecological footprint, the average citizen in those countries. And then we can shift to the per country view and some similar patterns, but you'll notice that the country of China, of India, of Brazil, those are a little darker than they were before, and that's just simply because of population. So if we look at the per country ecological footprint, China is huge. And then if we go down the row, we go all the way down to United Kingdom. So this is per country. Why do we see these differences? It's just population size. So the average citizen in China may have a smaller ecological footprint than some of these, but there's so many people in China that the overall footprint is greater. So that's why it's useful to look at it at per capita and per country. So one of the things I would highly recommend you doing, if you haven't done it already, is find one of the online calculators that'll do this for you. This is the one that I happen to use, footprintnetwork.org. It's a really easy one. And what it does, it just asks you a series of questions, I don't know, 20 questions or so. And eventually it'll generate this number for you, 4.3 Earths. And that just means if everybody acted like me, then we would need 4.3 Earths to sustain everybody. That means I'm using way more than what is allotted to me. And then it'll also give you more quantifiable numbers. So 7.3 hectares of land for my resources and my waste. And then it'll also break it down into categories like cropland or fishing grounds. Really interesting stuff on the carbon footprint. So definitely go through there, play around with it, click on the solutions button, really cool learning tool to kind of explore some of the solutions that you could pose to decreasing your ecological footprint. So speaking of footprints, let's look at mining. The human action of mining for minerals and resources and fossil fuels has a huge footprint, a huge impact on the environment. So by the end of this section, you need to be able to describe some general practices of mining and then describe ecological and economic impacts of natural resource extraction through mining. So to get there, we're going to describe surface and subsurface mining. Now, I'll say here, there are lots of types of mining, and where you mine and what country you're mining in radically changes what mining looks like. I have cherry picked a few mining practices to highlight, but by no means is what I'm getting ready to talk about an extensive look at mining. Just in the time constraints of this video, I had to kind of select some parts. So we'll describe surface and subsurface, and then we'll look at the idea of high grade and low grade ores and how that affects resource use and pollution. And then finally, we'll look at some broader environmental impacts of mining. So let's start with this question. What are we mining for? Why do we do mining? Why do we mine? Well, first of all, we're looking for metals, copper and iron and cobalt and gold. Tons of different metals are used in our everyday products. You know, the computer or the cell phone you're using right now to watch me contains some of those metals. So those metals are essential in making a lot of the products that we use every day. We might be mining for non-metal minerals. One that I like to think about is phosphate salts. Here in Florida, we have lots of phosphate mines, and phosphate is mined out of the ground and used for things like fertilizer. And then we could also be mining for fossil fuels, coal, oil, and natural gas. When we get into the energy unit, we'll talk a little bit more about some other oil and natural gas mining practices like hydraulic fracturing, but today we'll focus on coal mining here. And then when we look at these impacts of these metals or non-metal minerals or fossil fuels, we need to think about their entire life cycle. So not only is there an impact from mining, but we've got to refine and process these materials. We've got to transport them. We've got to use them. We've got to dispose of their waste. So again, think about the entire life cycle associated with mining and the use of these products. All right, so before we get into how it's mined, we need to look at, well, what's mined? So if I'm mining for, let's say, copper for say, I'm not simply going to dig a hole in the ground and find pure copper just waiting there for me to take out. The copper is going to be embedded within rock, or it might be gold, or whatever we're looking for is going to be bound typically within rock. And that's called ore. Ore is a rock that contains a concentration of a mineral that can be profitably mined and extracted. So this rock has something in it that I want to mine out of it. Therefore, the combination of rock and target material, that's called the ore. And that can come in two categories, high grade ore and low grade ore. And it's pretty self-explanatory that high grade ore has a lot of the stuff I want, as opposed to low grade ore has less of the stuff I want. So if we look at two rocks of the same size, two pieces of ore of the same size, high grade ore is going to have more of the material I'm looking for than low grade ore. Why does that matter? Because of this. I want you to imagine if you're going to start to mine for something, where are you going to go first? What are you going to mine first? You're going to mine that really accessible high grade ore. That's going to give you the most profit. So it's typically going to be more accessible, and then that piece of rock is going to have a lot of what you want inside of it. So that's what you're going to go to first. But eventually, that resource is going to be depleted, is going to get lower. So then what I'm going to have to do is look for low grade ore, pieces of rock that has less of my target material. And because it's low grade, to get the same amount, I have to mine more ore. So if we look up here at this high grade ore, it had 9 pieces, let's just say. But down here, the low grade ore only had 3 pieces each. Therefore, I needed to mine more land and do more mining and use more energy to extract the same amount of mineral. So there's an increase in use in resources, an increase in the water or the waste and pollution that I generate because I'm now having to go to lower grade ore. So let's look at the two big categories. The two categories that we're going to talk about today are surface and subsurface. And we're just going to start with surface mining. So surface mining is done when the ore is closer to the surface, and we can basically dig it out by standing on the surface with machines. Excuse me. And so one of the ones we're going to look at is strip mining. And this is an example of a strip mine here. And you can see these long strips back and forth. So this dark material is being mined. And when it's time to move over here to this next layer, all of the rock above will be removed and placed down into the trench or the strip that's already been mined. So it's probably easier to explain it from this picture. So if we look at this picture, the ore, the thing that I want, the rock that I'm trying to mine is down here at the bottom. But unfortunately, it is covered with lots of rock and soil and earth. That's called the overburden because it's over what you're trying to get, and that's a burden to remove. So we're going to take this overburden off and put it to the side, and now we can access the ore. Once we've accessed this ore and it's time for us to move over to this next section, we will take this overburden and put it in this strip that we've already mined, and now we have access to this ore. So it's these strips or consecutive areas in which we take the overburden, put it in the previous trench, mine the ore. And again, that material is called the overburden. So one of the things that I'm from Florida, I don't see a lot of mines, big coal mines or copper mines. That's not something I see a lot. And I remember first learning about mining and being amazed at the scale of the machinery that's used. These massive machines are invented to do this work. Now, those machines are obviously running on fossil fuels, probably, and the amount of greenhouse gases and pollution that's made from those machines is probably rather significant. So this is a little clip of a coal mine that really shows you the extent of the machines used.
Josh Gardner drives one of the trucks that work these pits. It's a 6:30 a.m. shift change. Time to go to work.
Hey, morning, Josh. Hey, what's up? Morning. Hey, good to see you.
Our ride is basically a dump truck on steroids. It stands over 2 stories tall and weighs almost 200 tons. But it seems dwarfed by the shovel at the base of the pit.
So if we pause here, let me move that out of the way, you can kind of see this is the coal that they're trying to get at, and everything above that would be the overburden. So right now, this is the coal that's being mined out, and the overburden that was up here is now deposited over here.
That's our first bucket in.
It felt like a small earthquake.
This actually is telling us how much weight we have on there. The first bucket was 68 tons, and then the second one, 60.
It looks like it's raining coal.
So we got 174.
3 bucketfuls, and we're on our way. One truckload like this can produce enough energy to heat a home for more than 40 years, or run your television for the next 2,000 years. All day long, Josh drives in a big loop, filling his truck with coal, dumping it, filling it up again. In a single shift, he can haul 8,000 tons.
Very cool. I just like to see the extent of the machines used. And that can give you a little sense of the environmental impact of some of these mining practices. Things like the construction of roads or the burning of fossil fuels. There's a lot of machinery that has to move in and out of these locations. Those need roads. That's obviously going to cause habitat loss and fragmentation. And then we've also got all of the dust and erosion that's happening. So a lot of dust in the air, particulate matter pollution, and then erosion. If we're removing vegetation, remember roots hang on to soil. And once those roots are gone, the soil is more prone to wind and water erosion. And then if some of those materials escape through surface or through rain or surface water, they can actually contaminate our surface waters or groundwaters. So that's surface mining. Now let's go way below and do subsurface mining. So this is when the target resource is simply too deep to use those machines we just saw. And therefore, deep mines have to be dug downward and then horizontal so that the human beings and the machines can get down there. It's much more expensive and much more dangerous for the individual workers. They have to be concerned about fires and explosions and mine collapses in that tight confined area way down below. And then there's also a particularly sad consequence for some coal miners and other miners that the dust can get into their lungs and cause a disease called black lung that's very dangerous. So subsurface mining has some unique health and environmental aspects to it. All right, so we've seen a little clip of surface. Now let's look at a little clip of subsurface. But what you should notice is the machinery that's involved is just as extensive. It's just way, way down below. All right. Oh, it is not working. I will see if I can put that in maybe next time we go. It's a cool little video. It just shows the machinery down below the levels of the earth. All right, let's keep trucking then. This is looking at mining in a less developed country. So one of the things that we need to think about is that in less developed countries, we may have mining operations that are more human-based and less mechanized. There may be less regulations involved. And so one of the unique things about gold mining is sometimes individuals will use mercury to separate the gold from the ore. And that mercury is obviously a poison that can cause mercury poisoning, or if you've studied Minamata disease, something very similar. So let's just look at a gold mining operation that will look radically different from those heavily mechanized versions we just saw.
Betty Nyamoita's hands can't stop shaking as she bands a mix of gold and mercury in a mining area in Migori, Western Kenya. She's done this for the last year, and she says her body tremors and slurred speech are some of the effects of mercury pollution. The mercury she bands up can remain in there for up to 1.5 years, and in water that goes up to 11 years. An estimated 1,400 tons of mercury from small-scale mining like this is released every year.
The tremors are sometimes very serious, especially if I'm burning the stuff when it's raining. Sometimes I can't even move.
That's why there's a global campaign headed by the United Nations to stop the use of mercury in unofficial gold mining. But alternative machines are still too expensive for miners like those who are here.
What they're doing now is separating the gold from sand and other particles using mercury. It's a tedious process. They spend hours doing this, and on a good day, one can produce on average a gram of gold.
So both of those videos you just saw, the surface mining in the United States and this more small scale mining in Africa, the goal is the same, is to separate that mineral from the ore, but how we go about doing it and the human and environmental impacts could be very different depending on where you are. So let's look at some wastes of mining. So remember, if we have our ore here and our target mineral, this little orange triangle, this is what we want. Well, the blue stuff is not what we want. So that's the waste. We've got to get rid of that. And those are called tailings. That's what's not desired from the ore. And those can be either stored in large piles or in tailings ponds. And why do those need to be stored and taken care of? Well, they could contain lots of this fragments of rock might have heavy metals in it. We wouldn't want those heavy metals getting into our waterways. And it also could have chemicals used in the extraction process. So these things have to be carefully monitored. And if there is a break in these dams or these piles kind of get exposed to rainwater and runoff or even into surface waters, that's going to cause a lot of environmental and human health impacts. Last year, there's been several large tailings dam failures recently, but there was a large one last year and it happened to be caught on camera. So you'll actually see the dam breaking and you can see all the tailings liquid starting to flow out. So sadly, that could cause loss of life, but also has environmental consequences as well. So we really need to be careful of those tailings, how we store them, because we do not want them to affect the environment or to harm people. And another unique aspect of pollution that comes from mines, especially abandoned coal mines, is called acid mine drainage. And this is when water flows over those tailings or flows over some of the coal that are in old mines. It can actually pick up some of that sulfur in the rocks and create sulfuric acid. Well, that's bad enough by itself, but then that acidic water can leach out heavy metals. So now you have bodies of water that are not only acidic, but have heavy metals in them. This is a news clip from a news station in Ohio that looks at some of these abandoned coal mines and the effects of this acid mine drainage.
You may not know this, but almost 90% of Ohio's electricity comes from coal-fired power plants. And while the newer coal mines are regulated, those old abandoned ones from a century ago are leaking toxins into our streams. Meteorologist Ben Gelber is just back from the Wayne National Forest in southeast Ohio to show you some big concerns about what those old mines are doing to our environment.
Dwayne, the Ohio Department of Natural Resources estimates there are more than 6,500 abandoned underground mines in eastern Ohio, and toxic mine discharge is still turning streams orange a century after the mines were closed for good.
Their parents always told us to stay out of the creek because it was sulfur water. It was a pretty orange color.
Dale Duvall grew up in the old coal mining community of Carbon Hill, which is along Monday Creek that winds through the Hocking Hills past Nelsonville to the Hocking River. Duvall remembers what it was like in the summertime, diving into a large, cool pond on the other side of the hill.
When you would swim in it and when you would come out your bathing suit and you would smell like sulfur.
This is the opening to an abandoned coal mine, the Essex mine, with toxic metal sludge. This is where the Sycamore Run comes through and carries pollutants into Monday Creek.
So while there may be stricter regulations on newer mining practices, some of these old abandoned mines that have been kind of forgotten could result in this acid mine drainage. So let's just do a quick check for understanding. And this is a graph that we need to analyze. So remember, whenever you see a graphical representation of data or a data chart or a data table or any kind of graph, slow down and really analyze the pieces and parts of it before you try to figure out what story it's trying to tell. Where I start always, and this is something that we've talked about before with the I-squared method, is look at the axes. The axes start the story off. So the first thing I see in the x-axis is years from 1900 to 2020. On this side of the y-axis, I see mill grade, percent copper. So I know that the word grade probably relates to low grade or high grade, and that's how much of the target material I want. So here it's copper. So down here, this ore has 0% copper, whereas this ore has 2% copper. All right, so I understand that y-axis. Over on the other side, it's milled ore. How much ore has been taken out of the ground? 0, 60. All right, so now that I kind of understand what's being measured, now I can look at the relationship. So the ore mined has gotten greater and greater and greater. So the overall trend is, as the years have progressed, I've just simply mined more ore. But also at the same time, the grade or the percentage of target material, which is copper, has gotten lower and lower and lower. So if we think about being able to describe that relationship, they're kind of inverted from each other. As one goes up, the other one goes down. But then if we had to explain it, this is where that understanding of high grade ore and low grade ore comes into play. That as I mine more and more of the high grade ore and I deplete that resource, what's left is lower grade ore. And to get the same amount of copper, I have to actually mine more and more of the ore. So a good example of how you might be presented with a graph and then describe the relationship, describe how the variables are interacting with each other from the graph itself, and then explain why that's happening. All right, so let's move from mining to urbanization. So after this section, you should be able to describe the effects of urbanization on the environment. So to get there, we're going to look at urbanization's effects on resource use and pollution. We'll talk about how that might impact climate change. We're going to look at a unique problem of urban areas, which is impermeable surfaces. Then look at another unique problem called saltwater intrusion. And finally, we'll look at the concept of urban sprawl and how that affects the environment. All right, so first of all, let's define urbanization. Urbanization is the overall trend or shift from rural life to urban life. A misconception point here is that urbanization doesn't mean the size of the city. Okay, urbanization just means that trend of a country moving from a more rural population to a more urban population. So there's more and more city life. It's not talking about actual square area here. That's more sprawl. So what does that really mean? Well, that shows a shift in development and resource use. So for example, if you're living in a rural area, probably your occupation, your way of living is more directly connected to natural resources and harvesting those natural resources, as opposed to in an urban area where you're not. Why is that? We have industrialization, we have economic development, the demographic transition. So the nature of the jobs themselves change as we move from an urban to a rural, or from a rural to an urban society. So as about 2008, that's when, as a planet, more people were now living in cities than in rural areas. So we still have more people, we still have people living in rural areas, obviously, but at this point in our history, more people live in urban areas. What does that do in general? Well, clearly a shift to urban living increases our fossil fuel use, not just for electricity generation, but for industrialization, for vehicle traffic, transportation, and all of those greenhouse gases getting into the air are, especially carbon, is affecting climate change. So here's a unique problem called saltwater intrusion, and this happens when urbanization happens in a coastal area. This is happening in some parts of my state here in Florida at this time. So before human beings were around, before urbanization started here at the coast, the pressure of this fresh water was enough to push the salt water to this boundary. So here's the salt water, here's the fresh water. And the reason this boundary exists is because there's enough fresh water to just push it to this line. This is a little brackish zone here where it's a little mix. But then we urbanized the coastal areas, and along with urbanization, you need drinking water. And so here in Florida, a lot of our drinking water comes from our aquifer underground. So these wells are drilled into the ground and start drawing up water. Well, what that does is it starts to pull the salt water, this boundary, further and further inland. And unfortunately, sometimes that can contaminate our wells. And so the salt water intrudes into not only our drinking water, but our agricultural irrigation as well. So a specific urbanization problem here on the coast. So I said before that urbanization was the general trend toward living in urban areas and city areas. Then there's this separate concept called urban sprawl. And this is the kind of oozing out of the city, just getting bigger and bigger and bigger and bigger. So the definition is kind of complex. So let's just read it here. It says, the expansion of human populations away from central urban areas. So we're moving away from these central urban areas into something like this, which is low density. So there's fewer people per area here. The density is lower. Monofunctional. So think about that. Think about if you walked in this one square block of this city, you might see houses or apartment buildings, stores, hospitals, schools. You would see a lot of different functions in this one block. Whereas here, all I see is houses. It's monofunctional and usually car dependent. This, if you live here, you don't need a car. There's public transportation, there's walking, everything is more compact. Whereas here, you would need a car. So it's the shift to this, from this high density multifunctional area to really low density monofunctional. So multifunctional, monofunctional. Why is this shift? There's an increased use of cars, so more roads can take us out there. And more wealth equals more choice. So as incomes increase, people have the choice to live elsewhere. There might be cheaper taxes, or you might have better jobs in the suburbs. You may just want a big yard. You want more property. There might be better schools or less crime, or simply for aesthetics. So there's a lot of reasons why this urban sprawl happens. And in some places, that urban sprawl is not sustainably planned. It just kind of oozes out, like I said. But some places are really doing smart growth, where that growth of the city is more planned out for less of an environmental impact. And we'll talk about that in just a second. All right, so this urbanization and urban sprawl, one of the most unique things that we really don't think about a lot is just the amount of impervious surfaces we make. So all of these roads and buildings and sidewalks and parking lots, if those were not there, rainwater would simply infiltrate into the ground and percolate down, and it would get back into the groundwater. But instead, we've kind of sealed it all up, and so the water now moves in a very, very different way. How does it move and what are the problems? Well, clearly, it's not going to allow our aquifers to recharge. Here in Florida, we need rainwater to infiltrate the ground to recharge our aquifer. But if we kind of put the Tupperware lid all over the land and kind of seal it up, the water can't get in there. So where does that water go? It runs off, so stormwater runoff. And if that water is not channeled somewhere, either into a gutter system like this or into a retention pond like this, we could have a risk of flooding, okay? So think about the water that travels, or the rainwater that travels down this street before it goes into this gutter. It's picking up lawn fertilizers and oils and cigarette butts and plastic pieces. So we can really get heavy contamination of surface waters just from this runoff over urban streets and rooftops and things like that. So in Unit 5, it explicitly says that this unit explores human activities that disrupt ecosystems, but it also explores methods to employ to reduce the impact. So we talked about these problems with impermeable surfaces. Now let's look at a few solutions. So the first one is permeable pavement. So they have invented pavement that will suck up the water. So if you look over here on the left-hand side, all the water that has fallen on this street is simply pooling up and collecting. It's not getting back down into the ground, as opposed to this permeable pavement, which allows the water to be absorbed. So I found a clip of a company that makes this pavement, and it shows this large dump truck full of water being poured onto the pavement. Well, if this was traditional pavement, the water would just pool up here and get deeper and deeper and deeper and eventually run off and carry whatever pollutants that are on the parking lot into waterways nearby. But instead, the water is absorbed into the pavement.
Well, my experience using permeable paving today is basically I've done a lot of residential block paving permeable systems. This is the first time I use a top mix permeable paving, so yeah, quite a bit of experience using permeable materials before. Top mix permeable material is so good, as in the way it can deal with the water in such a quick amount of time.
Very cool. So the water just gets absorbed right down into the ground.
Obviously.
So another solution to reducing urban runoff is planting trees. So planting trees in urban areas not only provides other benefits like aesthetic benefits or clean air benefits or shade benefits, it also can help with this stormwater runoff. So the water, instead of simply running off, might actually get down into this grassy area where the tree is planted, and the tree can take up some of that water and get rid of it through evapotranspiration or just using it. Or it can just let it get down into the groundwater again. So there's some definite benefits of this urban forestry idea to deal with runoff. Another one is increased use of public transportation. And a great example of that is Curitiba, Brazil. So if we have more public transportation, that means we would in theory have less vehicles on the road, and therefore the less need for more roads, which are impermeable. So shifting really heavily to public transportation decreases the need for more and more roads. And Curitiba, Brazil did a really interesting thing. As the city was growing, it grew the city along its transportation hubs, its public transportation routes, so that no matter where you live in the city, you could get on a piece of public transportation and get somewhere else. This would be kind of the opposite of that sprawl where it just kind of oozes anywhere it wants. The city has purposefully planned their city's growth based on their public transportation lines. And therefore there's less need for cars and less need for roads. And then finally, this kind of dovetails with that conversation, but sometimes cities can increase their population and capacity by growing up as opposed to out, the opposite of that sprawl. And so that's going to shift everybody to areas, like I said before, where you're going to have mixed land uses, different zoning. Zoning is how a city decides what goes where, whether it's a business or a residential area. So if you have smart growth, maybe you have mixed land uses so that your school and your job and your grocery store and your house are all within walkable distances from each other. And different modes of transportation are available in terms of biking or walking, but overall it's building up, not out. And obviously that's going to reduce the impermeable surfaces and reduce the problem of that stormwater urban runoff. All right, so let's do a quick check for understanding here by looking at a FRQ. This is from 2015. This is FRQ number 4. And it starts off by saying the term urban sprawl describes the expansion of cities into rural areas. This phenomenon has occurred around the world and has had economic, health, and environmental consequences. So the first question says, A, describe 2 causes of urban sprawl. So just take 20 seconds or so and jot down some ideas of describing causes of urban sprawl. All right, so you may have thought of things that we mentioned on that list just before. So changes in transportation use, lower gas prices, better roads, that might be able to get you out of that city center into a suburban area if that's your choice. Lower cost of living, higher taxes in the inner city, or that quality of life category of, you know, having a yard and less blight or less crime. So there's lots of reasons that people would shift from living in the city center out toward the suburbs. So this person says, A, urban decay. A lack of money and infrastructure in inner cities causes problems with crime and job opportunities. These problems cause people to move away from the urban areas and into more rural ones. Okay, there's one. Increased prosperity. As income in countries such as the US increase, people seek more land and larger homes. This desire for more property pushes people to the suburbs for more room to live. So good, just 2 good descriptions of why we would see that sprawl. So the second one says, B, discuss 2 human health effects associated with sprawl. So we've described what sprawl is. Now we want to think about human health effects. So take a few seconds to think about that and we'll look at the answer. So you may be thinking about the air pollution in city centers that might be really problematic. That air pollution might cause respiratory problems, obesity because of less walking around. You're more reliant on cars and other forms of transportation. Hearing loss from noise pollution, that was a really interesting thing. Reduction in disease spread in lower density areas, that's a human health effect. So let's take a look at this person's response. Urban sprawl means that cities are spread out further. Increased use of automobiles to get around means an increase in air pollution. In big cities, photochemical smog causes many health issues such as asthma. Boom, there's a good discussion of the air pollution problem. Second one, increased automobile use means that less physical activity for the average person. When they drive places, people don't walk or get as much exercise. This can cause obesity, heart disease, and cancer, among other things. So there's a good description of that shift in activity level. So this next one is the last one we're really going to look in detail here because this asks you to look at a graph. Again, I'm going to ask you time and time again, when you see a graph, slow down, deconstruct the graph, look at the pieces and parts, and then step back and say, what story is it trying to tell you? So let's do that. So let's start with the axes. So we're going to look at the x-axis down here. Density, persons per hectare. So that means over here, it's really not crowded. Over here, it's really crowded. It's high density of people, low density of people. Okay, I got that. On the y-axis, it says relative annual per capita petroleum use. So annual, so yearly per person crude oil or crude petroleum use. That means down here, I'm hardly using any crude oil. Up here, I'm using a lot of crude oil. So now that I got my axes under control, now let's think of what story that line is telling. That means somewhere like Hong Kong, it is very dense, but the average citizen is not using a lot of crude oil. And then over here in Houston, for example, not very crowded at all, very spread out. And this person is probably using way much more fossil fuels than someone in Hong Kong. So that's a good describe answer to that. But the explanation would come into play that probably if you're living in Hong Kong in a highly dense area, you're using less fossil fuels because you're walking a lot of places. As opposed to if you live in Houston, you're relying on cars a lot to get around from place to place. So I'm going to jump to the last part here. E talks about highway systems, and this asks you to describe 2 methods to reduce harmful effects on wildlife populations. And this was the conversation about wildlife corridors might come into play, or building roadways around habitats. So not only do we need to think about housing and transportation, but literally the road that we're building is taking over natural habitat areas. All right, I'm going to jump through this for time's sake here and kind of go to our summary. So we talked a little bit about mining, talked a little bit about urbanization, discussed what a footprint is, an ecological footprint, and then we looked at those solutions to reducing urban runoff. And several times today, we've looked at graphs and tried to interpret what those graphs were telling us about these problems. So your homework for tonight, no homework. Happy Friday, no homework. So have a really good weekend, and we will see you next week. And just as a final reminder, today is the last day to communicate to the College Board if you have connectivity issues in terms of internet or mobile tools, or if you know someone who does. So please be sure to contact them by today, please. Thanks again. Have a good afternoon, and I will see you next time, apes.